Dennis Kisina is my name. I'm going to be talking about code coverage using Clover. This is what I'm going to be covering during this two-part series. The first part will be in regards to Clover. The second part will be on SonarQube. So I'm going to cover in this first part of the series, I'm going to cover what is code coverage, how code coverage works, what is Clover, what problem does Clover solve, what you can do with Clover, how Clover works, and finally, what options you can configure in Clover. So what is code coverage? I'll give two definitions to try to make it more clear. Code coverage is the percentage of code which is covered by automated tests. This metric aims to measure number of lines covered by test cases. So, if you're familiar with, I'm assuming you're familiar with writing tests for your code. So, code coverage is the number of tests per methods or the block of code or statements you have. That is the code coverage. The other definition is code coverage is a measurement of how many lines or blocks of your code that are executed while the automated tests are running. Then, so how code coverage works? There are basically three different ways of implementation of code coverage. The first one, and what I'm going to look at, is the source code instrumentation. This is how the tool Clover implements code coverage. And I'm going to give an example to make it a bit more clear what I mean by source code instrumentation. So this approach, it's a technique actually, adds instrumentation statements to the source code and compiles the code with normal compile tool chain to produce an instrumented assembly. I will go a bit deeper into it in our next slide. I think the one of how Clover works, that's where I will tackle a bit deeper through an example. Then the other code coverage technique is intermediate code instrumentation. Here, the compiled class files are instrumented by adding new bytecodes, and a new instrumented class is generated. Okay. Runtime information collection is another technique for code coverage. This approach collects information from the runtime environment as the code executes to determine the coverage information. Okay. So we're going to cover code coverage in regards to Clover. So what is Clover? Clover is a tool that is used for what code coverage and testing for Java and Groovy projects. Clover uses source code instrumentation, as I had said earlier. By that I mean, as every line of code is executing, it keeps on adding some kind of information to track what has been executed and what has not been executed. That is how it will come up with the metrics for your coverage of code. As I said earlier, I'm going to show you how Clover works. So when you run your tests a report will be generated containing all packages, each class with each package, and corresponding line coverage, branch coverage, and complexity. As you can see in this example, you say you have a line of code A is equals to B plus C, or A is equals to, or D is equal to A plus 2. That is 1. Now, when this executes, you will see that OpenClover will add on more content to try and track the lines of code that have executed. Actually, it is more clear on the B example. Actually, this one doesn't have, but this is what has now. If you look at this code as it executes, Trump TPM1, TPM2, now those are the instrumentations that Clover adds to your code, and it is what it will use to determine the metrics for the code coverage. So what problems does OpenClover solve? As you are aware, as a developer, you'll be very many on the team developing on the same code base. But how do you ensure that the code is tested properly and all the team members are on the same page? Okay, so ensure that the code is tested and the code is of high quality is one of what OpenClover will address. So it shows developer teams which area of code that have been tested and which ones have not. Your whole code base will be on OpenClover, and whatever has been tested and not tested, you will be able to see. And so it gives an insight on whatever code is lacking and whatever percentage has been covered by your tests. These help the team, of course, to know, and as maybe a Scrum Master, you will know where to concentrate and what to do, or as a project lead. Those are some of advantages of what OpenClover solves. So what can you do with OpenClover? OpenClover generates several reports, in-depth reports of your classes, the methods, which you can use to understand your code base, and you can even drill down. We shall look and you see how the different views of OpenClover are, but it will show which projects, which code base is at highest risk, which one is the most complex, which methods have not been tested. It has a lot of information that you can use to know the status in terms of code coverage of your code base easily. What options can you configure for this code OpenClover? The first is statements. You can either choose to configure and you view results based on statement execution, or you do branch execution. These are your for loops, decision statements, basically, or based on methods. So without further ado, let me get into the demo for OpenClover. Via open my Eclipse. I've already installed OpenClover, as you can see. Actually, if you were to go to about Eclipse installation details, I have my OpenClover here installed. I'm not going to go through the installation of OpenClover because it will take a bit of time. I'll make another video on that. So we have OpenClover here installed, and these are our projects that we want for OpenClover to be monitoring and giving us the tricks on each. So the first thing is, how do you add a project to OpenClover to be monitored by OpenClover? So you right click on the project go down here where you see Open Clover and come at enable, the project. And when you do that, it will bring up a window and you can select the project. If you want multiple projects, you can select under here and you will be able to add the projects. So I have these two projects, bank account solution and bank with mock solutions, which I've added under Open Clover. So just a brief to go over the different views that Open Clover has. So by default, when you open Clover, you will have 4 views. We have the Coverage Explorer view, which you can see here. We have the Test Run Explorer view. We have the Test Contribution view. And we have the Clover Dashboard view. Okay, I'll go over them briefly so that you know what they are used for. Then, so we start with maybe the Explorer, the Coverage Explorer. Oh, okay, no, let's start with, because the assume you have, let's start from, you have just added your project to be monitored by Open Clover. You will not have these metrics. So how do you get the metrics from your project? You will have to come here to build and run. This option here will run the whole project. It will run and build the whole project, and you'll get these metrics for the different projects that are under Open Clover. This is to run an optimized test. For example, you have very many classes or methods. Test methods are many, and you want it to be quick. This will run based on priority, where a change has occurred, because Open Clover is aware of all your files. So when you make a simple change, let's say in any in any of these files, okay, you just make a simple change, Open Clover will track and will know. So the next time you run the tests and you don't want to go through all the other classes that have not been changed, you just run this and it will prioritize to run the changes, the classes which are affected by where the changes, and the class itself they will be on top. So that's the difference between this and that kind of launching. So the Coverage Explorer, it has, as you can see, it has the different matrices. Let me just go over each. So as you can see, we have here the show. When you click on this, it has application classes, the test classes, so you can view based on what you really want to see. These are different kind of what you want to see from your matrices and what you prioritize. You can select from here and the Explorer. Then there is settings. Settings, there are different ways you can track the changes. You can track by coverage, look up for updated coverage every 20 seconds. This is how often it will go through your code base to see the changes. You can set all of them under here, under settings. These are elements which we are currently tracking and our Open Clover. As you saw it, the ones I added, these are the ones. If I was to remove, let me show you, so that we no longer monitor under Open Clover, it would disappear from there. Let me select that. See, it goes. And even the icon, the one for Open Clover, see, it's not there. So if we are to add again, so we know for this project, there are two options. You can, it comes and you can see there are no matrices for this. It just shows this is the coverage, the percentage coverage. So, okay. So if we want to run for this, we shall select, we come here and we run for that. Still running. Let's hold on. So you see, now we have the coverage. Then we have also another matrix here, the average method complexity. This is the one, and also this is another matrix, which is the complex classes, and we have other matrices here, the structure for our project, which is selected here. As you can see here, we have 5 packages. It has 8 files, it has 8 classes, 40 methods, the number of statements and branches. That is how detailed Open Clover can give you the view of an overview of your project. It will even show you the tests which are executed, the number of lines of code, the source code. So this is all under the coverage. Then we have the next tab, the next view, which is the test run explorer. So these are all our tests that have been run under this project. Same applies to this. And as you can see, it will give you if it passed or failed and the number of seconds it took for that test to run. Okay. Then there is up here, as you can see, there is the Java View editor. It will show you the coverage, the methods that have been covered under your tests which you are running. So if the color coordinated green, when a method is highlighted green, that shows tests have passed and there are tests which are being executed on it. There are other colors. I don't know if we have here another color, which is maybe yellow, red, but here all the tests are being executed on those methods, so that's why the coverage is green. If I see another color, I'll show you. Okay, we'll go to the next window. So this was the test run explorer. Then these are for the contributors to the code base. If we had different contributors to the code base, they would show up here. Then the other view which I'm going to talk about is the dashboard. The dashboard, the Clover dashboard, has a bird's eye view of everything that is happening in your project. You can see the coverage, the classes, the elements, the test results, the complex, what classes are the most complex, what packages have the most complex classes. You have a general overview from here. Even here, this is for the packages. This is for the classes. And then you have this, which shows you which classes have the most complexity. And here you should know that the bigger, the more complex that class is. And you can click from here and you dive deep into that code where that complexity is, and you see whatever you want to do. Then we have a coverage tree map report. It's same as the coverage cloud report, but now this will show you a simultaneous comparison of the classes and packages by their complexity and by their code. So if it is red, this is very complex. This is not that complex. That is okay. This is for the tests. So that is how it would show them. Yeah, so in general, that is the general overview of how it works. There are different configurations, as I showed you. You can make whatever you want to be viewing. For example, you see this is based by class, by methods. You can dive a bit more deeper into this, but that is the general overview. Here in this second section for code testing, I'm going to talk about code testing using SonarQube. I'm going to talk about, this is the general overview we're going to cover. What SonarQube is, how it does work, what problem does SonarQube solve, what can you do with SonarQube, and what options you have that you can use for configuration. So what is SonarQube? SonarQube is an open source static testing tool which is used to analyze software. It is used by developers to manage source code quality and consistency. Some of, for example, during static testing, the code is not running. The tool will be going through the code as the developer is developing the code. So some of the code quality checks could be the potential bugs in the code as you are writing, the code defects, to design inefficiencies, code duplication, lack of test coverage, and excessive maybe complexity in your code. That's what SonarQube can do to some of the checks that SonarQube will do. So how does it work? As I said, it is a static testing tool. So SonarQube uses static methods for debugging by examining source code before it is run. That is to say, test the code without being executed. It does so by analyzing the code against a preset of coding rules and ensures that it conforms to the guidelines. Okay. So the developer, the team lead, could set the guidelines and it puts the rules in SonarQube so that the rules are enforced by every and followed by every developer on that project. So it takes the code while it checks the code while it is being written, and it performs an analysis on it, and based on a set of rules that are already predefined, it sees whether the standards of testing are performed or not. Suppose in my team, we have some standards that are set by the team lead, as I had said earlier. If we want to ensure that these standards are met, we use that tool. Okay. So what problems does SonarQube solve? It detects bugs. Okay, as you're writing the code, that is one problem to do. To check for code smells. To check also for security vulnerabilities in your code. For example, you're writing an application for authentication and you are putting the password directly. It will check and will warn you about this. The other thing is activated rules. It activates the rules that are needed for the project, and you can even separate these rules based on the project that is being implemented. So the next thing that I'm going to cover is to go over an overview of SonarQube in use. Let me end this. So I have already installed SonarQube, and I have my server running, as you can see on my computer. I'm not going to go through the installation process of SonarQube. So I have it running, and I have the instance already here. If you want to go to SonarQube, you will come to local, then the port, and this is what will be presented in. I've already logged in with the default credentials, that is admin, and this is what you will have. I have imported some test projects which we're going to use to go over SonarQube, and just a brief recap of, not really a recap, but a brief how you can have your projects in SonarQube is you will go to the project, for example, the banking with, you copy the sonar-project.properties folder. It has some information there which you have to type in. After that, you will open this folder in your terminal, okay, and you paste in a command for it to import this project. This is the command that you type in so that SonarQube can import the project into this this dashboard, and we see it there. And before you do that, you create a project under here. When you create the project, let's just go through it. I will create one. You will create a key for the project that you want. You create a display name for the project, and then you set up. You will be given a code that you will execute in that project folder, the one which I came here, the one which I showed you here. That's the one you will use, so that you can identify projects based on your on the user. So let's just go a brief overview of the whole tool. As you can see, I'm under projects, and these are our current projects that SonarQube is analyzing. You can see the different matrices, the bugs. Right now, this is a small project, so you can see the bugs. There are 0 vulnerabilities on our project, 0 hotspot reviewed, there is negative, code smells are 27. The Java language we have set, which the project is written in. Those are just some of the few things that you can look at from this the main screen, but we're going to dive in a bit deeper to have a look at them. And you can see there are different matrices here, reliability of our project and the rest. So let's say we go to this project. Overall, as I had said, you can see the bugs, the reliability, the code smells, the coverage, the number of lines they have covered, the duplicates, 0%. Let's go to security issues. SonarQube will show you exactly where the security issues, and will show you what it is. Is it a major issue? Is it a minor? And you can open and go deep. You can open and go to that real issue where it is, and so that you can address in your code from here, as you can see. this is showing this block of commented out code line of code should be removed. So you can see what it is saying. This is a major issue. You have to remove your code smells because this comment does not make sense. The rest is the other issue. You see, it is warning us about system.out. Which to tell we should replace and rewrite to the logger with system.error. So you see, these are some of the issues that SonarQube has identified without even running the code. To give us the hotspots where the trouble is in your code, though here we don't have any. Then it will give you these measurements, the reliability of your code. You can have an overview in a graphical manner. You have a look at it and see. Though we don't have a lot here to see based on our code. Even the coverage, you can see we don't have the coverage here. Then our code, of course, where it is, and the activity. So though that is under, those are our projects which we have. Then what you can do with SonarQube is to you set the rules that can be enforced and followed by people on different projects. This is where you come to set the rules. As you can see, these are some of the inbuilt rules. You can add your own rules, and based on the project, and they will be enforced. So this is where you come and add the rules. Then the code quality profiles. These can be based on the language. You can set profiles based on your language, a project which you're going to do, specific projects. You can set them and enforce them based on that. Yeah, basically that is it for those are things that you can do and set. That's the information you can see from SonarQube, and that's how it can help you write better code and have a successful project implementation.